have on our board, we have complex numbers. The question is, what are complex numbers? Complex numbers are numbers that have two parts, okay? Complex numbers are numbers, or is a type of number that has two parts. It has the real part and the imaginary part. It has the real part and the imaginary part. Okay? Now, other numbers are categorized as either real numbers, rational numbers, irrational numbers, integers, and others. But for complex number, it has two parts. It has the real part as well as the imaginary part. Now, with that being said, let us look at the standard equation, or will I say the standard form of complex number. Z is equals to x plus I, y. So looking at this standard form of complex number explains what exactly complex number is all about. Now, this is the real part, this is the real part, and this is the imaginary part. Okay, now this particular course has several parts, but this particular part that we are doing is part 1. Okay, so we are doing part 1, or let's say complex number part 1. I'm not going to do everything for this video because it's going to be very long. So the real part is without the I, while the imaginary part is with the I. Now let's move to the next thing. Now, in the course of this complex number, we are going to be discussing so many terms. So I'm going to be writing all those terms out. Let me write those terms out. Okay, the first one is conjugate, and is noted Z bar. Okay, so the second one, which we are going to be discussing, is modulus. Modulus is denoted Z, absolute value of Z, or R. Okay, you can be taking note of all of these things. The third one that we're going to be discussing is argument. Argument. Okay, so argument is denoted theta. The fourth one is the forms of complex numbers. Forms of complex numbers. Don't know if you can see this clear. Okay, now to start with, conjugate. What is conjugate? Conjugate is still the same conjugate you know in sword. Okay, if this was to be a sword, we say we have a sword of, let's say, 2 plus root 2, and you're asked to find the conjugate. It's just for you to change the sign. If it is plus, you change it to minus. If it is minus, you change it to plus. So the conjugate of this is going to be 2 minus root 2. Okay? Now, the same thing with complex number. Since complex number is somehow related to sort, but not exactly, because the reason I'm using the term somehow related is root 2 is irrational. Okay? And complex number has the irrational part of it, which is also known as this, something that has to do like the irrational part of it, which is the imaginary part of it. So let me just put it that way. So it's still somehow relating to this. So just like you have a complex number, let's say Z is equals to, let's use the general form, X plus IY. And then you were asked to find Z bar. Okay, what are you supposed to do? This represents conjugate, right? So because of the fact that we have this sign up here, which is Z bar, so your plus, since it's plus, it will now become minus. So that is it. I think that is all for conjugate. I don't want to talk much on anything that is not really complicated. Let us see if we can finish first part and then see if we can do the second part before it goes dark. Now, the next thing is modulus. The next thing is modulus. We have been able to discuss conjugate. So the second thing we have here is modulus. Modulus. So modulus is denoted absolute value of Z, or r. Okay, so what does modulus entails? When you hear the word modulus, modulus can also mean the absolute value. Okay, the absolute value of something, the value that you, while looking at it, like what value can you estimate that thing to be, is actually the modulus, or can I call it magnitude? Okay, so that's by the way. So this is the general form of complex numbers. Okay, the general equation or the standard equation or the rectangular form. I'm still coming to forms. There are several forms. So it's mainly called the rectangular or the standard form, because from this form comes every other forms of complex numbers. So in this case, if you're asked to write modulus, what are you supposed to do? So for modulus, it's either we are using absolute value of z, right? So the absolute value of z now is, the formula is square root of, you are going to square the real part plus you square the coefficient of that I, which is the imaginary part, which is y squared. So whatever you get is your modulus. Let's take for instance, we have z to be equals to, let's say we have or let's say we have 2 minus 3i. Okay, 2 minus 3i, and then we are asked to find the modulus. What are we supposed to do? So either we call it this or we call it r, is equals to the square root of 2 squared plus minus 3 all squared. So by so doing, we have square root of 2 squared 4 minus 3 squared 9. So we have the square root of 13, and that is our modulus. Okay, so this is what modulus entails. So let's move to arguments. I don't want to waste time on all of these terms. Okay, so now for arguments, let's see. If I'm too fast and you want to take note of those things, you can repeat the video, or maybe you can forward the video backward so that you can get all those things and write them down. Now the next thing now is arguments. That's the third thing we have here, arguments. So argument. What about argument? We say that the symbol is theta, right? We have two major arguments, or when it comes to argument is just like saying the angle. Since it's a complex number, it's not like every other number. It has to do with angle. Okay, so it has an angle, and that angle is referred to as argument. We have principal argument and we have ordinary argument. But for the sake of this part one, I'm not going to talk much on those types of arguments. Now, the argument I'm going to be talking about is the argument that is due to this particular cause. Okay, now, and the argument which is mostly used is the ordinary argument. Okay, the ordinary argument. So moving on. So what is argument? We said that argument is angles, right? So since argument is angle, in what sense or how do we obtain argument? Apart from how we obtain argument, being an angle, is it going to be in degrees or in any other form? So in the course of this course, it's going to be in radian. So whatever argument you are getting, you are going to express it in what? Radian. And remember, I said that argument is more or less an angle. Let's say somebody tell you that the argument is 30 degrees. So it shouldn't be in 30 degrees. Like, it shouldn't be in degrees, rather. It should be in radian. So what do? You convert 30 degrees to what? To radian. And the simple way of doing that is, you remember that your pi, to convert to radian, is written in terms of pi. Okay, so your pi is actually 180 degrees. So what angle will be 30? What pi, rather, what is the value of 30 degrees in radian? Okay, so you cross multiply. So by the time you cross multiply, you have pi times 30. First multiply this. Pi times 30 is 30 pi divided by 180 degrees. You bring it down. 30 go in 180, we have 6. So our 30 degrees is pi over 6. Now another simple way of doing it is take that value, like this 30 degrees, that angle that you are given, divide it by 180. So that will be 30 divided by what? But make sure you put pi attached to it, and then you get your answer, which is still what? Pi over 6. So this is what we call argument. But then how do we obtain this argument? What has angle, which is argument, got to do with complex number? That is where the question lies. What has angle, which is the argument which we've just discussed, got to do with complex number? How do we obtain it from that complex number? So let's do that quickly. Now, this is the standard form, right? And we said that this is the real part and this is the imaginary part. So to obtain your argument now, which is theta, is equals to the tan inverse of, first of all, always remember that the imaginary part is the bone of contention, because that is what brings about complex number. So because real part is real numbers, which everybody already knows. So it's going to be that one to be considered first before the value here. Okay, so this is it. So let's take an example. Let's say we have a complex number of 1 plus I, right? This is actually 1I. So in this case, and we are asked to find the argument. So what do? We say, okay, the argument is going to be the tan inverse of, remember we are going with this first. So that's 1 divided by 1, right? And what is the tan inverse of 1 divided by 1? Divided by 1 is 1, right? What's the tan inverse of 1? The tan inverse of 1 is what? In degrees, we have 45 degrees, isn't it? Because the tan inverse of 1 is 45 degrees. Okay, so in that case, since we have 45 degrees, how do we express it in terms of what's it called? In terms of radian, because we have this, we need to express it in terms of radian. So how do we do that? You tell yourself, okay, in terms of radian, remember what I said, 45, then you attach pi divided by what? 180, okay, degrees. So 45 going 180, our final answer is going to be pi divided by 4, right? So that's going to be our final answer. Okay, so that is it. It's as simple as that. So we have gotten our what? Our argument. So our argument is this. Okay, now with that being said, we have been able to discuss conjugate, modulus, argument. Now the last thing which we are discussing for this part is the forms of complex numbers. Then we'll continue for part 2. Okay, so the forms of complex numbers. The forms of complex numbers. So let's move to that. Now this is where you have to pay massive attention. So the last thing which we are discussing, forms. So the forms of complex number. Complex numbers can be in these 3 forms, can be in any of these 3 forms. The first one is it can be in its standard form, which most people call rectangular form. The second one, complex number can be in polar form. Polar form. Okay? Then, lastly, complex number can be in a form called the Euler's form. The Euler's form. Okay, these are the 3 major forms. There may be other forms, but these are the 3 major forms which we have to be very conversant with. There's another one that is called the principal form, but I'm not going to be talking about that one here. So this is the one I'm going to be talking about. Okay, now I will discuss more on this. I will just say a few things about these forms. I'll just spot a few things about them. Then in part 2 of these complex numbers, which we are still going to be discussing complex variables. Okay, we will now discuss everything. So please, if you are new to this channel, make sure you subscribe to this channel, because by the time we do part 2 of complex numbers, which we also discuss complex variables, okay, you will get to know a lot of things regarding this. Okay, so let's discuss a few things about it. So standard form. So to start with, so standard form. So talking about the standard form, which is also known as the rectangular form. For the standard form, we already said that the standard form is z is equals to x plus I y. So this is actually the standard form of a complex number. So from this form, you can convert it to any other form, right? So from here, we usually mention modulus. We say that modulus or r, either you say absolute value of z or r is equals to the square root of x squared plus y squared. So I just want to recall. Now that is all for the standard. This is how the standard form looks. Okay. Now the next one is polar form. What about the polar form? Polar form. Some people call this polar form the trigonometric form. Okay. So because it's with respect to trigonometry, so trig form. Because it has some trigonometric functions like sine, cos, and others. So for this one, since complex number has something to do with tan, and tan has a relationship between sine and cos brings about tan. I think before now we should know that tan theta is equals to sine theta over what? Cos theta, right? So we know this before now. So since we know this before now, polar form now is now going to explain to us further how to represent the standard or the rectangular form. So in this case now, the z in this case is now going to be, first of all, your modulus, right? Your modulus, then into, we have, first of all, remember, if you remember, when we're looking for our argument, we did the tan inverse, right? We said that tan inverse argument is equals to the tan inverse. We first of all started with the imaginary part. We said y before what? X, which is to say that y is cos and y is sine and what? X is cos. So that means what is coming first is cos. So we'll say cos theta. Don't forget that this theta represents what? Argument. Then plus I, then sine theta. Okay, so that is it. So this is what? The polar form. This is the polar form. So this is the polar form actually. We're still going to discuss this in our next video. So the next one now is, we'll still talk about this the more. Polar form can still be expounded further. Okay, so this is the basic one. So we'll still talk about this. Then lastly, we have the Euler's form. So this form is with respect to exponential logarithm. So we have it to be, first of all, you write your modulus, then e to the power of I theta, right? So this is it. Now, all of these forms are related, but I will see you in my next video. In the next video, I'm going to be explaining further on these forms. So thank you for watching to this very end of the video. So do not forget to share this video, because in our next video, I'm going to be explaining further. I'm going to be telling you how all of these forms can be converted from one to the other. And then see you in my next video. Bye.